Good morning, everybody. We have a kind of a discrete math version of a quartic equation that was a problem SMO Open review type setting. Now, a couple of important things here. We're looking for all the values of m. You might be led to believe there's just one value of m, but it turns out there's more than one. This distinct part is very important. Okay, so we're given the sum. They're not really the sum of the zeros, but if you expanded this out, they would be the sum of the zeros, really, after you got sorted out the constants. But there's not enough information to do a Vieta's type approach. So let's dive in and look at another approach here. Now, since it's integers are emphasized here, it's not a bad idea hardly ever to determine the prime factorization. And it's not too hard to see. I believe that's 11 squared times 13, and that's not too hard to discover. I won't go through that, but there's a divisibility test. You can alternate here and get 0, I think, or maybe 11. But anyway, 11 and 13 are divisors, and it's 11 squared times 13. So you only have two distinct prime divisors, okay? So let's see how we might use that. Now, the one way to look at it is just spread these primes out however you can. And so we might consider putting 11 here. Now, since they have to be distinct, you can't put 11 again, right? So you have to put minus 11. All right? And then all that's left here is 13. So what do? Well, okay, you have 4 factors here, but you only have 2 distinct prime divisors of the constant term. Okay, so you have no choice here. You have to cancel this out because this is positive. So you would have to put a minus 1 right here. Okay, no, you have to put a minus 1 right there. All right, if you're going to put 13 here, you'd have to put a minus 1 here. And you see how we've covered all the prime? We have 2 copies of 11, and the minus signs cancel out, and we maintain this positive constant. Okay, so the big idea here is to note that these divisors, or these factors on this side, would add up to 4m minus the sum of a plus b plus c plus d. Okay? All right. And again, this would be the sum of this factor, this factor, this factor, and this factor. And that's easy enough to see, right? All right. Now, we also know that these factors are going to add up. You see how the minus 11s cancel out here? These factors are going to add up to just 12. Okay, and now we get to use the vital piece of given information. These a plus b plus c plus d add up to 60. Okay, and so from here we would get 4m minus 60 equals to 12. And that would say that 4m is equal to 72, and so this would imply that m is equal to 18. Click, click, click. All right. Now, it's tempting to think that you're done right here, but notice there's nothing that would have prevented us putting 13 here and minus 1 here. Okay? That would make it different, right? And so if you do that, if you put 13 associated with this factor and minus 1 here, and you can, it doesn't make any difference what order here. I mean, you can either way. All right, so you get minus 11 here and 11. All right. And so you see what would happen here. You would get, if you follow this through, you would have, what do we have here? 13 minus 1. And so you could, what would happen here is you would end up with minus 12 here, I think, this time, right? What does that add up to? Oh, maybe. Let's see. Does that make any difference? No. So, y'all, maybe what I should say here is make this one minus 13, right? Okay, to make it different. All right. So let me erase right here. Okay. So we'll do it like this, right? Okay. Now, I believe that, yeah, that makes a little more sense in terms of it being distinct from the previous case, right? So you see right here what happens now is that you would get 4m minus 60. Now you see this sums up to negative 12. This sums up to negative 12. And so what would that end up being? That would imply that m is 12 itself, right? Is that right? Yeah, because you would have 48 minus 60. Yeah, so this implies that m is equal to 12. Okay, and I'm claiming these are the only two answers. I wouldn't call this a rigorous proof, but these are the only distinct, since this thing is sort of a symmetric expression, these would be the only distinct arrangements of these factors 11, 13, and 1, and then, of course, the minus signs. All right, so let me know what you think. I think I've gotten all the solutions here, but I got m equals 18 and m equals 12 for the two solutions. Notice you could find the a, b, and c, but it's not necessary. Okay, the a, b, and c d values will be different down here than up here. But you didn't have to find those as far as what the question asked for. So what I got, and let me know if you find any others, but I got m equals 18 and 12. And I think the problem for the SMO worked out where it was just one. I think it was a cube, it was a fifth degree equation, okay? Fifth degree equation, and I think there was only one answer to that. But in this case, I'm pretty sure that these two cases would be the only two cases. But again, I'm not positive. That's what I think. All right. Thanks for viewing.